Hello and welcome back to Maths with Mr. C, and today we are proceeding with our series in solving the general solutions. In part 1 we had a general solution for cos, so today I have a very special general solution equation that is sin x plus 30 is equal to cos 2x. Why did I choose this one? This is a very special general solution equation. And if we are to analyze this graphically, this represents the graph of sin x plus 30. That is the graph of sin x shifted 30 degrees to the left, and then the graph of cos 2x. You normally find this general solution equation in the question involving the trigonometric graphs. So here we have two graphs, sin x plus 30 and cos 2x, and our aim is to find the coordinates of the points of intersection of the two graphs. Now, what is our point of departure here? When you look at sin x plus 30, you are tempted to expand this by the compound angles and also replace the identity for cos 2x. That would be a very correct replacement for sin x plus 30 and cos 2x, but it is going to land you nowhere. It's more like a plane that is going to crash. This equation has got its special way of solving it. Now, let's look at the special way of solving it. You solve this equation by the co-functions. And take note, cos 90 minus theta is equal to sine theta. So we are to change sin x plus 30 using this co-function identity. This co-function identity, unfortunately, it is not available in your formula page, so it must be in your head. Now, if we are to simplify and replace that, it means the left-hand side becomes cos 90 minus our theta will be our x plus 30, and then you close. Take note, I have made use of these brackets. If this bracket is not available, this is going to have a very big impact on this solution. It will be wrong. So make sure when you quote it in here, you quote it with the brackets. So this is equal to the cosine of 2x. Now, if we have got two equations, for instance, we have got cos A is equal to cos B. This can only happen if and only if A is equal to B. So this is what we are applying here. Now we are already in our general solution and also the reference angle, because this is a cos and this is a cos. And remember, the general solution for cos, we said it is a plus or minus. So how do we quote that? We then quote 90 minus x plus 30 is equal to plus or minus 2x and then plus 360. Okay, it's very important to quote two things here, the plus or minus for the 2x and then the plus 360k right at the beginning. If you forget this one at the beginning, it will affect the whole solution. Now we've got two solutions in here. We will start running with the plus one and simplify it algebraically. So therefore, the first one, 90 minus x minus 30 is equal to 2x plus 360k, and then you divide both sides, but not yet. You can collect like terms. X and minus, they join together, we have minus 3x is equal to, and then we have negative 90 going that side, and then we have got positive 30. So this becomes minus 60 plus the 360k. Now we can divide both sides by negative 3, by negative 3, by negative 3. This means our x is equal to 20 minus 120k. Okay, so this becomes solution number 1. Remember, our k is an element of integers. Now we are not yet done. We also have to do the minus. So for the minus, 90 minus x minus 30 is equal to negative 2x plus 360k. Then we collect like terms, minus x plus 2x. This becomes our x is equal to, and then here we have again the same, positive 30 minus 90, it gives us minus 60. That is minus 60 plus 360k. Our k is an element of z, that is the set of integers. So this is solution number 2. Now, this is the first one, and this is the second one. Now, with trigonometric questions or these equations, they come with different types. Some of them is just a general solution, which means it ends here. Some of them it's a particular solution. For instance, we have to extend this in a specified domain. Let's say we are to solve this between minus 360 and 360. So we can create a table where we extract the two solutions. The first one is x is equal to 20 minus 120. So we write here 20 minus 120k. So on this one, 20 minus 120k. And then the next one, it's minus 60 plus 360k. Minus 1, 0, and 1 as our first extracts. This can extend up to negative infinity and also positive infinity, but I just chose these ones because the domain is not that wide. Then the substitutions, I prefer to start with the 0. So substituting our k as 0 here, we are going to get our 20 degrees. Then here we are going to get our minus 60. Then we can go to the 1. If we multiply this one by 1, this gives us 20 minus 120, which is minus 100. And then here by 1, this is 360 minus 60. This gives us 300 degrees. And then we go to the minus 1. This is 20 minus 120 times 1, which means this gives us 140 degrees. And then for the minus 1 here, this gives us minus 420. And then we check according to the specified domain. 140 is okay, 20 is also okay, minus 100 is also okay. We have minus 60 is also okay, 300 is also fine, except 420, which is outside our domain. So therefore, the ticked ones, 1, 2, 3, 4, 5, they become our particular solution to this general solution. If you are to check, for instance, if we pick 300 and plug in, when you want to check, we will have sine 300 plus 30. We need the value there, and then that is on the left hand side. On the right hand side, we need to compare with cos 2 multiplied by 300, that is cosine of 600. If you check from your calculator, the sine of 330, what does it give us? The sine of 330, what do we get? Anyone with the value? Sine 330. Negative 1 over 2, and then cos 600, negative 1 over 2. So each of these, which means the left hand side is equal to the right hand side. So which means the solutions are balancing. So this should happen to all of them that you have actually quoted in the question. I hope you are going to enjoy this one. Okay.